Let's decode the shielding effect visually. Here you can see this is the nucleus and these two are the valence electrons. Here is a ring. This ring represents s and p orbital. Now s orbital has a spherical shape and p orbital has a dumbbell shape. Now when we fill a lot of electrons inside the s and p orbital, it becomes so dense that it becomes like a protective wall. So here it is going to act as a shield, meaning the outermost electrons will not feel the pull by the nucleus. Means the nuclear pull felt by the outermost electrons is very less. Why? Because this is acting as a shield. Now I replace this s and p orbital with a d orbital, as you can see here. Now this is a d orbital and it does have a direction. The lobes that you can see are pointing in a particular direction. But as you can see something different, the lobes or the d orbitals are quite diffused. There are some empty gaps in between. So in quantum mechanics, these empty gaps are called as nodal planes. Means the probability of finding electron in these empty gaps is 0. Okay, there is no electron over here. So you can imagine these lobes to be electrons. They have electrons in it. So I can say that maximum electron density is found in these lobes, which means there is a leakage in this orbital, and that leakage is nothing but the open gaps. And because of that, the outermost valence electron, which are the 4s. So here we can talk about our 3D series, the transition elements, and this d orbital is our n-1d. So these 4s electrons will experience a nuclear pull by the nucleus because of the leakage, yes, and that is the reason the atomic radii of the 3D elements is quite small. Okay, so you can say when you go across the period, the atomic radii decreases. All right. Also, these d orbitals offer poor shielding to the outermost electrons. All right. So because the lobes are concentrated only in a particular direction, they will not offer stronger shielding as s and p orbitals offer. Okay, that is why we can say that d orbitals offer poor shielding and hence they attract the outermost electrons. Okay, the nuclear pull experienced by outermost electrons is maximum. All right, and this is the reason atomic radii is small. Okay, thank you.